One thing that I've got set up is I've got this is my little power supply that you can't really see here, but I've got 5 volts coming out of here and just hooked up to one wheel right here. And if I apply power to it, we get our motor turning and our wheel turning. Kind of shaky. Not a great product. Now, this was going clockwise. And if, like with a DC motor, if I want it to go in the other direction, I have to reverse these two, reverse the polarity here of my supply, and now it goes in the other direction. And if my job was to control this wheel and make it go forward and backward, and I had to switch wires all the time, I'd be fired very quickly. So there has to be a better way to do this. So a simple approach is to use some switches, and maybe I can find some way to do some switches here to make to move this motor in both directions very easy. And I'll leave it to you as an exercise to try and draw it out. If you had just switches, how would you make it so that you could reverse the direction of a motor very easily? So go ahead and do that. Write it on a piece of paper. Try it out because it's a fun little exercise. But if you're not patient, I'll give you an answer. This is a diagram that I found on the internet. I think it was ST Robots or something. But you can do it with what's called a double pole switch. So a double pole, double throw switch means that the switch, let me just get one here. So here is a big double pole, double throw switch. So you've got 2 poles, which means that this is the common, and I can throw the switch this way or I can throw the switch this way. So if I have a power here, I can make it come out this way, or I can make it come out this way, depending on which way I throw the switch. There's 2 throws, so that's what makes it a double throw switch. Most switches that you see, normal close a switch, is a single pole, single throw, which is just one half of this. So if all I did was I did this, and let's say I never had this second half of my switch here, and I just went click, 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 that's a single pole, single throw switch. So now I've got a, if I only look at one half of this, I've got a single pole, double throw switch. With both of these are not connected. These 2 pieces of metal here are not connected through this piece of plastic here. So I've effectively have 2 switches with 1 piece of plastic holding them together, which makes it a double pole, double throw switch. 2 poles, 2 throws. Double pole, double throw. So from one switch, I'm effectively getting 4 different positions, 4 different switches out of it. And that's what this shows here. Right? If you want to see the actual diagram for it, 3 and 4 are the commons, and they switch between 1 and 5 and 2 and 6. I'll try and turn that a little bit so you can see it a little bit better. So 3 and 4 switch between 1 and 5 and 2 and 6. So there's your diagram there for a double pole, double throw switch. And in order to make this motor go in both directions with my double pole, double throw switch, what we're going to do is we're going to take power, this is the symbol for a battery, and we're going to apply it to our poles, and then we're going to put a reversing, a crossover wire between these 2 sides, and then we'll take one side of it, either this side or this side, and we'll bring that out to our motor. So if we think about that, in one position, let's say we have our switch over in this position, so like this. If we're looking at this diagram and we put our switch like this, then the power comes in here, it comes up through here, through our motor, back down, through here, and back to the negative. So now we've got positive coming in this way, well actually it goes the other way, so and coming out the other way. Now if we flick the switch this way, then our power comes in here, and then it goes over this crossover, and it comes in this side of the motor. It comes out, down this side of the crossover, back up to the negative. So through this, we've just made the power either go this way through the motor or this way through the motor with a single switch. So let's just try that. So we've got this wired up. We've got our power coming in to the middle poles, just like we see here. We have our power coming into our 2 poles. So there's our plus and our minus. Then we have these 2 coming out to these 2 ends, like here. And then we have white crossed over to here and green crossed over to here. So if we watch our motor and we put it in this position, clockwise. If we go the other direction, counterclockwise. So there is some simple motor control using a switch. But this is not going to get me very far. I have to be here to physically move this switch back and forth. And we want to make an autonomous robot. We want to be able to make a computer do this switching for us. Right? We don't want to have to physically move a piece of metal in order to change the directions of our motors. And also, we have 4 motors. Right? We have 4 motors here, and we don't want to have 4 of these switches and then try and coordinate all 4 of these at the same time. That's just crazy. So what we're going to have to do is we're going to have to replace this with some electronics to do the same thing. And fortunately, there are circuits that can do that. And I talked a little bit about that in part 1 of the video. There's a thing called an H-bridge circuit, which effectively does the same thing as what you just saw here. So let's just look at what an H-bridge circuit is. It's kind of the same thing. We bring in our voltage and we have 4 switches on each side of our circuit. And by switching opposite switches, if I close this one and this one, now power will flow through here, through the motor this way, out, and back to ground. If I switch this one and leave these 2 open, then power will go this way and then out the other way. So that way we can switch the motor and instead of using physical switches here, we'll use transistors, and it's a special type of a transistor called a MOSFET, which is a stronger, more powerful transistor. And just Google it. There's all kinds of YouTube videos explaining how MOSFETs work and transistors work. I won't get into that gory detail there. But the trick to this is that you have to make sure that you switch this and not this and this. If I switch this and this, like 2 of these here, then I've got a short. I've just got electricity going right back in and everything blows up. It's not very good. Same thing happens on this side. So I have to make sure that these 2 are switched atomically as one action. And then when I want to change direction, these 2 have to open and these 2 have to close almost instantaneously. And that's where the electronics comes in, that we can do things that fast. That's what we're going to do. And in order to do that, we're going to use a little motor controller. And that's exactly what this thing is. This thing is an H-bridge circuit. And it has a few things on it. This can control 2 motors. These are the 2 terminals for the motors. This is motor A, motor B. You can pass in either 12 volts or 5 volts. It can operate off either. From what I've been reading on this thing, it can get a little hot with 12 volts. These motors only require 6 volts. I think they'll even run as low as 3 volts. So we're just going to run off the 5 volts. And then there's these lines here, which are enable and drive, or direction, I think. Right, so if I bring one of these pins up to 5 volts, it'll change the direction one way or another. And then if I change the enable line on it, the motor will go or the motor will stop. So the faster that I switch that on and off, So, well, let me explain how that's going to work. So let's go back to our little switch here. And I've got this motor here. Now, if I want to go fast, I just leave it down like this. And that's as fast as it's going to go. But let's say I wanted to go slower. Well, what I can do is I can sort of pulse it like this. Right? So now I'm getting full power at short little intervals. And I'm terrible at doing this. But you can see what's happening here. I get full power for a short burst. So effectively, I'm moving slower. Now, if I replace my terrible shaky hand there with a piece of electronics, and I control that at a steady pace, then I can do that to all 4 motors at the same time and get full power and little tiny movements of the motor. And that's what this does. By sending a pulse into the enable line as a square wave, then I'll be able to control these motors very specifically, make them go fast or make them go slow depending on how long I leave it on for. So that's going to be our next step. We're going to hook this up, try a few things, and then ideally hook it up to an Arduino and get a computer to operate it. So let's try that.